Hello, geometry students. Today we're going to be covering the Unit 8 review. Hopefully you watched the video that goes over the rest of the packet, the workbook. And if you did, most of this review will seem not too bad. There are some parts that get a little confusing or things that weren't explained well in the packet, but I'll be going over all that. Also, if you want, it's a good idea to go through the review ahead of time before watching this video and just answer all the ones that you feel comfortable with. And then once you've done those, then go back and watch a video and you can check your answers and all that. Also, whatever I write, you should be writing. That way you'll get the fullest understanding and I guarantee you, you'll do better on the test. Okay? So let me go ahead and share my screen here. And go ahead and turn to the review. Let's see. And on the very first two questions, here we're basically filling in these blanks here. So if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So basically what that's saying is if you have a circle and then you have a tangent line, then this tangent line will be perpendicular to the radius touching there. So this would be a right angle. Number two, if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So basically this is showing like from this one here. If you have some point and then you have a tangent to that circle here, see ML is tangent, but also MN is tangent. What it's saying is that these two segments, MN and ML, these would be congruent. Okay? That's what that's saying. Okay. That being said, let's go ahead and start some of these problems. So it says ML and MN are tangent to circle O. What is the value of X? So in this case, the value of X, the way you can find it is just know that these two are supplementary to each other. So if you know this angle, then we can find this angle because they should add up to 180. So that's going to make X 60 degrees. They're supplementary to each other, meaning they add up to 180. Okay. A tower has an observation deck about 330 meters above ground level. About how far is it from the observation deck to the horizon, knowing that the Earth's radius is 6,400 kilometers. So here they kind of like, they try to trick you here. And it's going to be like this on the test as well. Notice that the tower, its length is in meters, but the radius of the Earth is in kilometers or kilometers. So watch out for that because we really want it in kilometers. So this 330 meters, we want to convert that into kilometers. Now, the way you do that is you think of 330 meters with a decimal at the end. You move that decimal 3 spots. So that would be 0.33 kilometers. Okay. So that's the first step. Make sure all your measurements are in the same type. So you want, if this is in kilometers, you want this in kilometers. You want the same type of measurement. Okay. Same denomination of measurement. Okay. With that being said, it's saying that this line, TE, is tangent to the circle C, right? So since this is tangent, we know that this is going to be a right angle. So what kind of shape do we have here? Well, we have a right triangle. I'm going to go ahead and draw it to the side here. Here's where T is. That's the top of the tower. E is where the right angle is. And then C is here. The length from E to C is 6,400 kilometers. And the length from T to C, well, from T down to C is the 6,400 plus 0.33 more. So 6,400 0.33 kilometers. And we're looking for the distance from the top of the tower to the horizon. So that's going to be our unknown here. We'll put an X. Now, when we're finding a missing side length of a right triangle, how do we find that? Well, we can use the Pythagorean theorem. A squared plus B squared equals c squared. Now the c is always the hypotenuse. So the c that's over here, that's the hypotenuse of our triangle. It's always the longest side. So in our case, c is going to be 6,400.33. And since it's c squared, we're going to go ahead and square that. The a and the b are going to be these two lengths here. It doesn't matter which one's which, but I like to put my variable first. So I'll put my variable for a. And then for b is the other leg, which is 6,400. Okay. So it's going to have x squared plus, so 6,400 squared. So that's 6,400 times itself. It's a large number. So it's 4,0,9,6,0,0,0,0. Okay. Then over here, 6,400.33 squared gives me 4,0,9,6,4,2,2,4.1. Now to get x by itself, what we're going to do is subtract this from both sides. This 4,0,9,6,0,0,0,0. Subtract that on both sides of the equation. That way you get x squared by itself over here. So when you subtract that, that leaves you with 4,224.1. And on the left side over here, we have x squared. So now my goal would be to get rid of the squared. Now the way you get rid of the squared is by using square root. Square root and square cancel, leaving you with just x. Square rooting this gives you, I got 64.99 or 65 roughly. And again, this is in kilometers. Whoops. There you go. Okay. Question 5. So here, what is the radius of circle C? So we have circle C, and we're looking for the radius. That's this length x. Notice the radius could also be considered from here to here, which notice they're both length x. So that's fine. And notice also that this is a right angle. So meaning that AB is tangent to the circle. So since it's a right angle and we're missing a side length, we can use the Pythagorean theorem. In this case, which side length would be, so we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. Which side length would be the hypotenuse here? Would it be this 10? Would it be this x? Or would this be the x plus 6? Well, the longest side is always your hypotenuse. That's what we'll go for C. And the 90-degree angle always points to your hypotenuse. So we know our hypotenuse is x plus 6. Notice that whole length of that side is x plus 6. That's going to get squared. The other two side lengths also get squared, so that's going to be x squared plus 10 squared. These are your two legs of the right triangle. This will give you x squared plus 100, right? 10 squared is 100, equals, now to the side, I'm going to go ahead and do this work over here, but basically we're going to do x plus 6 squared, meaning x plus 6 times itself. So a little bit of algebra here, but we're going to go ahead and multiply these two binomials together. So first we multiply the x times both the terms over here. So x times x, x times 6. So x times x is x squared plus x times 6 is 6x plus, then you multiply the 6 times both terms. So 6 times x and then 6 times 6. 6 times x is another 6x plus 6 times 6 is 36. We look to see if we can combine like terms, And yes, we can combine the 6 x's together. So that's going to leave us with x squared plus 12x plus 36. Okay. We can go ahead and subtract x squared from both sides of the equation. Since there's an x squared on both sides, I want to cancel that. That'll just simplify things a bit. So over here on the left, we have 100 equals, and on the right side, we have 12x plus 36. For my next step, to get x by itself, what we're going to do is subtract 36 on both sides. So over here, we're going to have 64. Over here, 12x. Lastly, divide both sides by 12 to get x by itself. So that'll give you that x equals 64 over 12. You could leave it as 64 over 12 or reduce the fraction or put it as a decimal, 5.33. Now make sure you can do this in your calculator and you understand every step along the way. If I went too fast, just go back. Make sure you understand how we got each step along the way. Number 6, is ML tangent to circle N at L? So to tell if something is tangent, what you're going to do is you want to check to see if this is a right triangle. Because if it's a right triangle, then we know that this is a right angle, which means we know that this is tangent. So how do we check to see if it's a right triangle? Well, we could check the Pythagorean theorem, a squared plus b squared. And we want to see, does it equal c squared? So will it equal like that in this case? This will only be equal if this is a right triangle. So in this case, what's our longest side? What's our hypotenuse? That's 8. 8 is our hypotenuse here. So that's going to go over here. See? 8, the hypotenuse is always the longest side. The other 2 side lengths will go over here, the 2 legs. I don't know if this is equal, so I'm going to go ahead and put a question mark there. So 4 squared, that's 16, plus 7 squared, that's 49. And I'm trying to see, is that equal, is this equal to 64, right? 8 squared is 64. We can go ahead and add this together. So that's 65, I believe. Yeah, 65. Well, that's not equal to 64. So these are not equal. So then we would say this is not, so since these are not equal, that means this is not a right triangle, which means this is not a right angle, which means ML is not tangent. So ML is not tangent. To N. Okay, circle O is inscribed in triangle ABC. What is the perimeter of triangle ABC? So here's triangle ABC. Okay, now since it's inscribed in the triangle, what that means is each side of this triangle is tangent to the circle. So because, like, for example, let's just look at here we got point F, and then here I'm just gonna call this point E here, okay, where this touches the circle. Notice that CF is 6, and CE should also be 6 because this is tangent and this is tangent, so these need to be congruent. So if this is 6, that means that's 6 as well. Okay. Similarly, if BD is 16, then BE should also be 16. because B is equidistant there. Okay. Same thing here. If AD is 12, then AF should also be 12. These are all centimeters. So what's the total perimeter around the triangle? So basically adding up all the edges of this triangle. So 12 plus 6 plus 6 plus 16 plus 16 plus 12. So the total perimeter of this triangle is 68 centimeters. Okay. Now, for these 8 through 11, you can find these definitions in the book, Theorem 12-4, 12-5, and so on. I don't really like these questions because if you notice, it says within a circle or congruent circles, congruent central angles have congruent blank. 12-5 says the exact same thing. Within circles or congruent circles, congruent central angles have congruent blank. The only difference is this one says arcs, this one says chords, but both are true, right? So when you're on the test, it'll say theorem 12-4 and theorem 12-5. Just remember the 12-4 one is going to be arcs. 12-5 one is going to be chords. You just got to memorize that, okay? Also, look at this. Within a circle or congruent circles, congruent chords have congruent arcs. So if you just got to memorize which number for the theorem goes with which word here, okay? I'll give you a hint. On the test, these questions come in this order, okay? So you're going to expect to see 12-4, then 12-5, then 12-6, these questions in that order, 12-7 after that, okay? But basically what this first one says is if you have a circle and you have two central angles, and these two central angles are the same, then they have congruent arcs. So these arc lengths will be the same. Number 9 is basically saying that the chords connecting those arcs would be the same. Congruent chords produce congruent arcs. And we're going to talk more about it in question 12, so don't worry about it too much. And then within a circle or congruent circles, chords equidistant from the centers are congruent. Okay. So number 12. In the diagram, circle O and circle P, circle O is congruent to circle P. Given that BC is congruent to DF, what can you conclude? So right here we have congruent circles, right? That's one of the conditions here, congruent circles, congruent circles, congruent circles, congruent circles. So we're going to be using some of these formulas here. So we have congruent circles, right? It says they're congruent. Given that BC is congruent to DF. So BC, this length here, is congruent to DF. So we have two congruent chords. So because we have two congruent chords, what can we say? Congruent chords have congruent arcs. Okay, so then that means that arc BC is congruent to arc DF. Right, this arc is congruent to this arc. Okay, notice I put a little arc symbol over these. Okay. We could also say that these two central angles are congruent too. So angle BOC will be congruent to angle DPF. Now on the test, you're going to get a question just like this. And I think there's a mistake on it. I don't know if they've fixed this mistake yet, but basically you want to click the answer choice that says both A and B. Okay. And it's weird. It'll be like, and I think answer choice B is the one that says this, right? So it'll say answer choice B, both A and B, which is kind of weird, right? That's not how it should be, but this is the correct answer. So just the one that says both A and B, I don't remember what letter it is, but the one that says both A and B, that's going to be the correct answer on that one. Okay, I'm just going to give that one to you because that one is clearly a mistake, and I don't think they fixed it. Okay, what is the length of RS in circle O? So here we have circle O, and we want to find the length of RS. So that's this length here. What is this length? Okay, so you might notice these have little tick marks here. That means these are congruent. So if the length of PQ is 13.5, then the length of QR must also be 13.5. Right? These little tick marks mean they're congruent. So what's the length of PR? What's the length of PR here? So all the way from P to R. Well, that would be 13.5 plus another 13.5. So that's 17. So PR is 17. So what would be the length of SR? Well, it would be the same. Oh, did I say 17? I should say 27. Okay. So the length of PR is the same as the length of SR, both 27. What is the value of R to the nearest tenth? So in this case, we're trying to find the length of the radius here, R. That's the distance from K to L. Now, what kind of shape do we have right here? Well, a triangle. More specifically, it's a right triangle. So how do we find a missing side length on a right triangle? Hopefully you know by now, it's the Pythagorean Theorem. This is when you have two side lengths of a right triangle and you're missing the third. Now, in our case, we have R here, we have 5 here. Well, what's the length of LN? Well, right here it says 18 centimeters, but that's the length from L to M. So L to M is 18. So what would be the length from L to N? Well, that'd be half that. That's 9. So in this one's example, which side length should be the C? Is it the R, the 5, or the 9? Well, the 90-degree angle always points to the hypotenuse. So it always points to the longest side. In other words, that'll be the C. So in our case, that's going to be R. Now, we don't know what R is yet, but we'll figure that out. The other two side lengths, 5 and 9, those will be your legs, the legs of this triangle. Doesn't matter which one's A, which one's B. They're interchangeable. So it's 25 plus 81 equals R squared. This will be 106 when you add those together. To get rid of the squared, use square root both sides of the equation. That'll give you R all by itself. And the square root of 106 is 10.3, let's say. Okay, that's length of R in this case. Okay. Here's 3 more questions you need to know. Theorem 12-11 states, which is the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. Okay, which we kind of talked about that before. So if you have a circle and you have some angle like this, if this arc is, let's say, 100 degrees, then the inscribed angle that makes that arc would be 50 degrees. Okay. Two inscribed angles that intercept the same arc are congruent. So if you have this angle that grabs this arc right here, and then you have another angle that grabs that same arc, then that means these two angles are congruent. Okay. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So if you have a tangent and a chord, then whatever the degrees of this arc, let's say the degrees of this arc is 150, then the measure of this angle would be half of that, so that's 75. Okay. These will come into play right now. So if I know that this is 62 degrees here at angle RQS, see how that's RQS is 62 degrees, this angle. What would be the measure of the arc from R to S? So that arc, according to this first one, that should be double that. So in this case, A would be double this, so that's 124 degrees. Okay. Now, let's take a look at the next. Now we want to find this angle B, right? So that's angle RWT. RWT. Now that covers the arc from R all the way to T. Okay, you see that? So what's this arc from R to T? The arc from R to T, this arc is how many degrees? Well, it's 124 plus 31 more. So that's 155 in this case. Okay, see that? So the B in this case is going to be half of that. Remember, the inscribed angle is half of that arc. So what's half of 155? 77.5 degrees. Okay. What is the measure of angle 1? So here we're trying to find the measure of this angle here. Well, again, this is an inscribed angle, and we can look at this angle. Angle 1 grabs this arc. So this arc is a half circle, right? It's a semicircle, we would say. So how many degrees is in that arc? Well, these numbers don't matter, actually. But how many degrees are in this arc is 180 in this arc. That covers from the two endpoints of this angle. So the inscribed angle should be half of that. So that means this is a 90-degree angle. So the measure of angle 1 equals 90 degrees. Okay. So whenever you have that semicircle there, we know the inscribed angle that forms that arc will be 90. Right? Which makes sense because it's half of the 180. In the diagram, SR is tangent to circle at Q. If the measure of the arc PMQ is 220, so PMQ, this arc is 220 degrees. What is the measure of angle PQR? So we're looking for the measure of angle PQR, the measure of this angle here. Okay. Well, this actually goes to the last theorem here, number 17, theorem 12-12. If I know this arc, then this angle will be half of that. So if this is 220, then this angle right here is 110 degrees. Now, don't get confused. That's not the answer, because that's the angle of SQP. I'm looking for R, PQR, right? So I'm looking for this angle here. But what I do know is that on a straight line, now I'm just going to draw this straight line. If I know the measure of one of those angles, I could find the measure of the other because they form a straight line together, and a straight line has 180 degrees. So these are what we call a linear pair, and a linear pair are always supplementary. They add up to 180. So if this one's 110, that means this one must be 70. Okay, so the measure of angle PQR equals 70 degrees. All right, here's a couple more definitions you got to know. All right, I know these theorems. I know they hurt a lot of students, but just know for these two, their answers are the same. It's intercepted arcs, okay? So the measure of an angle formed by two lines intersect inside a circle is half the sum of the measure of the intercepted arcs, okay? We'll see this theorem in action in number 23. Theorem 12-14 states, the measure of an angle formed by two lines that intercept outside a circle is half the difference of the measure of the intercepted arcs. Okay. Okay. Here we're looking for x, and we're basically going to be using this theorem here, 12-13 theorem from question 21. And basically to find this, you just take the average of these two arcs, right? It's the average of these two. So you're going to add those together and divide by 2. The way you find average of anything is you add them up and divide by how many there are. But in this case, there's only 2 items. So to find the average between them, you simply add them up and divide by 2. So that gives me that the measure of angle x is 69 degrees. Okay. Question 24. A satellite in a geostationary orbit above Earth's equator has a viewing angle of Earth formed by the two tangents to the equator. The viewing angle is about 21.5. So we can see that viewing angle right here, 21.5. What is the measure of the arc of Earth that is viewed from the satellite? So we're looking for the measure of this arc here that the satellite can see. Well, if you remember from when I covered it in the lesson, this angle and then this arc add up to 180. Okay, so you can just do 180 minus the 21.5, and that gives you the viewing angle here. Or not the viewing angle, but the amount of degrees it can see of the curve. So this would be 158.5 degrees. 158.5. Okay, question 25. Find the value of the variable in circle n. So I don't think we did anything quite like this one in the packet, but they did give you the formula, and the formula looks like this here. So y plus z times y equals t squared. And kind of we're using this picture here where t would be like where x is, y is where the 16 is, and z is where the 8 is. So in my formula here, y is right here. That's where 16 is. So on my formula, I'm going to replace y with 16. I'm going to replace z with 8 because z and 8 are in the same position. So the z in the equation is going to replace with 8. Again, another y, so that's going to be another 16. That's where y is. Equals t is right here. That's where my x is. So that's going to be x squared. Okay, now we can go ahead and work this out. So 16 plus 8 is 24. And that gets multiplied with the 16. Equals x squared. So 24 times 16. That's 384. Equals x squared. Now, how do we get rid of the squared? Well, hopefully you remember, to get rid of the squared, you square root both sides of this equation. So that gives me that x is 19.6, roughly. X is approximately 19.6. Okay. Circles in the coordinate plane. So hopefully you remember the standard equation for a circle. If not, you need to know it. And it looks like this: x minus h squared plus y minus k squared equals the radius squared. And just a reminder, the h and k tells you the center of the circle. So this tells you the center, gives you the x and y coordinate of the center. And r is the radius. Okay. So in our question 26, what is the standard equation of a circle with center at -4, -2, and a radius of 6? So this tells you your h, k, and r. And you just replace them into this formula. So notice our formula says x minus h. So that's going to be x minus -4. X minus -4. So that's going to make it x plus 4. So when you see that minus negative, that's going to make it a plus. I know it's a little tricky, but that's how it works. Then y minus k is in our formula, y minus k. So y minus -2. Y minus -2 makes y plus 2. Equals r squared, so that's going to be 6 squared. Okay. If you just leave it like this, I'd be happy, but you may also see it like this. So I'd suggest writing this as well. This doesn't change. Y plus 2 squared equals, and sometimes they'll square this out and call it 36. Okay, either way. I think on the test they write them out like this. But same type of question you'll see on the tests. What is the standard equation of a circle with center at 4, -3 and passes through the point -1, 1? So we haven't seen one like this in the packet, but we're going to be using that same standard form of equation. In this case, we don't know what r is, and they don't give it to us either. They don't tell us what r is, but we can figure it out. So, but they do give us the center. It's 4, -3. So let's start writing our equation. It's x minus the center. This is our h and k. So x minus 4 squared, x minus h is 4, plus y plus 3 squared, because again, it's y minus k, so that's going to be y minus -3, makes it a plus, equals r squared. Now, we don't know what r is yet, but that's okay. They give us this other point, -1, 1. So what we can do to help us find r is we can plug in this point into our standard equation for a circle. So this is going to replace the x and y in our equation. So if I replace x with -1 and y with 1, this is what it'll look like. -1 minus 4 squared plus 1 plus 3 squared equals r squared. This will be negative 5 squared plus 4 squared equals r squared. Negative 5 squared, that's 25, plus 16 equals r squared. By the way, when you do this squared, it should always come out positive because that negative gets squared. So that's like negative 5 times negative 5. That's positive. So that's 41 for r squared. Okay. We don't have to, if you want to find the radius, you could square root both sides. But in this case, it's not necessary because notice our equation leaves it as r squared. So we could just put that, replace r squared with 41 because r squared equals 41. So now our standard equation looks like x minus 4 squared plus y plus 3 squared equals r squared, which is 41. Okay, and that's your answer. So this is the equation of a circle that passes through this, or sorry, passes through this point, and this is its center. Now we can go ahead and use our knowledge now to graph circles. So what is the graph of a circle with the equation x plus 2 squared plus y plus 2 squared equals 64? So first thing I want to find is I want to find my h and k, my center, and I want to find my r. So my h and k is negative 2, negative 2. Because it's x minus negative 2 in order to get that plus 2. Okay. Same thing with the y. So then here, our radius, well, remember the r squared is usually what's right here, so that's 64 in this case. So how do I figure out my radius? Well, you square root both sides to get me my radius. R equals 8 in this case. So what we're going to have is a circle with radius 8, and its center is at negative 2, negative 2. Now, when you're graphing it, be careful because notice it's going, notice these numbers are 10s right here, right? So if this is 10 right here, that means they're counting by 2s. You see that? 2, 4, 6, 8, 10. Same vertically, right? Same on the y-axis. 2, 4, 6, 8, 10. So negative 2 is actually right here. See how that's negative 2 because we're counting by 2s? And then our radius is 8. So we want to go a distance of 8 in every direction. So we're going to go 8 to the right, 2, 4, 6, 8. Again, remember to count by 2s because each of these grid lines is by 2 now. And 2, 4, 6, 8. 2, 4, 6, 8. From the center, 2, 4, 6, 8. Once you have this, you can go and try to connect these points with a smooth curve to create your circle. Okay, mine is not the best. Hopefully yours looks better, but that's the general idea. Don't just make it like straight lines, okay? That's not a circle. Try to connect them with a smooth curve. Okay. All right, number 29. What is a sketch and description for each locus of points in a plane? So we're looking for points that are 1 inch from a given point C. So imagine we have a point C, and I'm looking for all the points that are 1 inch away. So I'm going to go 1 inch away in every direction. So this would be in the locus of points. That's 1 inch away. And this would also be in the locus of points. That's 1 inch away. And this would be in the locus of points, 1 inch away. In every direction, we want to be going 1 inch away. Now, how long could I be making these points for? I could be making these points forever, trying to draw every point that is 1 inch away. But you can see what kind of shape we're going to be making here. It's going to be a circle. Okay. If you really want to make this look nice, you can use an actual ruler and like draw points and measure the point's distance. Make sure it's 1 inch away. But what have we created? We've created a circle. So the locus of points creates a circle. Creates a circle with center at point C. And radius 1 inch. Okay. Last one was the locus of points in space that are R units from a point A. So here we have a point A, and we're going R units away. Now, we don't know what R is, but let's just pretend R is roughly this far away. So we want all the points that are that far away. Hopefully you can see already that that's going to create a circle. With center at point A and radius R. Okay. The locus of points forms a circle with center at A and radius R units. Okay. Okay. I hope that that made sense for the most part, and I hope you're able to get through it relatively painlessly. And if you understood everything on there, then the test should seem relatively easy. I would say focus on those definitions, make sure you got them down. Oh, and I do want to point out one more thing before I go. I'll show you here. So this formula will also be on the test. Okay, this will also be on the test. Hopefully you haven't signed off already, but this one will be on test, and this formula is on page 24 of your workbook, and you can see some examples of it, or we did some examples of it on page 27 of the workbook. Okay? Okay, so you need to know this. It's not on the review, but I'm letting you know that will also be on the test. Okay? All right. That was the last thing. All right, well, take care, guys, and I'll see you guys next time. Good luck on the test.